Okay, so another try getting this to load. I lost the problem set 6 and 7, but at least we got half of it. So for the first one, for 1a, when it says that you can't use fractional exponents or negative exponents, then usually what we do is a process called rationalizing. And so how we rationalize is wherever we've got a radical in our function, or in this case in our fraction, I'm going to rewrite 20 over the cube root of 2 as 20 over 2 to the 1/3. And the reason that I do that is if I want to get rid of the fractional exponents, then I'm going to need to multiply here by something that will make that exponent come out to a whole number. So if I multiply by 2/3, 2 to the 2/3, then I'm going to keep the base the same at 2, and I'm going to add the exponents. I'll get 3 out of 3, which is 1. And so that will actually get rid of the fractional exponent for me, but I have to do the same to the top as I do to the bottom. So we'll just put that in as 2 to the 2/3 for now. So I'm going to rewrite that down here. I'm going to have 20 over 2 to the exponent 1/3 times 2 to the exponent 2/3 over 2 to the exponent 2/3. And so the 1/3 and 2/3, those are going to add up to 1. So that's going to give me 2 to the 3 over 3, or 2 to the 1. And then on the top, I have 2 times, let me see now. So one way to write that would be 2 squared cube rooted. So I could rewrite it as cube root of 4, and that way I'm not using a fractional exponent and I'm not using negative exponents anywhere. And then I can further simplify this now because I just have 20 over 2, so 20 over 2 is just 10. And so now I have 10 times the cube root of 4. For the second one, that's pretty simple because it's 125 and it's to the exponent 1/3, and that just means the cube root of 125. So you could leave it like that because now you don't have any fractional exponents, or you could just work it out because the cube root of 25 is just 5. Okay, so that was actually B, not number 2, just to keep things organized here. Okay. If I look at question 2, I have $500 of a stock, and every year my stock is going to go down to 90% of the previous value. In other words, I'm going to lose 10% of the value every year. And so we need a function that shows the value after t months. So let's call that function f of t like they did. And initially I start with 500. But what's going to happen is at the end of the first year, I only have 90% of that left. So after 1 year, that's what my formula would look like. And 1 year is 12 months. And so if they're going to give me my t in months, I need to take my t value and divide it by 12 to make it into years. Okay, and so I think that's all that's required here. Yeah, so if it was 12 months, that would be 1 year. It would be 90% of its previous value. If it was 24 months, that would be 2 years. That would make it 81% of its previous value, and it would just keep going down by 90 or by 10% every year. Okay, if we look at the derivative for 1a, we are dealing with an e to the x function. And so I would prefer to look at it like this, 7e to the 1/5 x, like that, okay? We know that the derivative of e to the x is e to the x. E to the x never dies, and so we have the derivative just with the e part would be this times the chain rule, which is 1/5 for the derivative of 1/5 x. And there was a coefficient of 7 out front, so we're just going to leave that coefficient there. And if I multiply the 7 times the 1/5, I could write that all together as a fraction, 7 over 5, and then I would have e to the 1/5 x, or you can write it as x over 5 if you want. If I do b, I've got a exponential here, and so when I do exponentials, I'm going to use my logarithm for my derivative. So if I have y equals a to the x, then the derivative of that is a to the x times the ln of a. So I'm going to follow those same rules, only my a is equal to 2, and my x is actually 5x this time. And so I'm going to have, if this is y, I'm going to have y prime equal to a to the x, so 2 to the 5x, times the ln of 2, and then I should have squeezed this in down here a little bit. Let me just erase that and move it down so it's not confusing. So y prime is going to be 2 to the 5x times the ln of 2 times your chain rule, which is the derivative of the 5x that we can write in brackets. So that's a 5. And so I end up with 5 times ln 2 times 2 to the 5x for the derivative of that one. Okay, for number 2, question 2, they're asking for dm dt. So there's a couple of ways to do this. One would be to try and solve this equation for m, because usually if I have like a y equals 2x plus 3 or something, and I'm asking for dy dx, then I would have to have everything written in terms of y as a function of x. So if I can rewrite this equation as m as a function of t, then I could just take the derivative the normal way. But that would also involve cubes, because I've got an m cubed here. It would mean taking the cube root of 5t squared minus 70 over 3, and that's going to be kind of a more difficult derivative to take. The alternative is to use implicit differentiation. So every time that I take the derivative of something that doesn't have a t in it, I'm going to have to multiply in my dm dt, or whatever variable I have, dt. So it would look like this. I would go 3 times 3 is 27, m squared times dm dt, and then 70 doesn't have a derivative, it's just 0, and then I would have 10t on this side, and it's already in relation to t, so I don't need a dt or anything like that, and that would just be 1, right? So if I solve here for dm dt, I'm going to get 10t over 27m squared. I think we would just leave it like that. Only 3 times 3 is not 27. 3 times 3 is 9. Oh my gosh. 9m squared. 9. Sorry. All right. For the last 2 questions on this sheet, then, if I'm being asked to take the derivative of a ln of something, then I always start with the rule, which is the 1 over. If it's ln of x, it would be 1 over x. If it's ln of 12x squared, it's 1 over 12x squared. In my bracket, there's a chain rule because I can do a derivative there. It's 24x. So now I can simplify. 12 goes into 24 2 times, and x goes into x squared x times. So on the top I have 1 times 2, and on the bottom I have x, and so my derivative is 2 over x. And then let's do part b right beside it here. I've got log base 10 of 6x, and this works just like the lns, okay? So y prime would be 1 over 6x times the chain rule of the derivative in the brackets, so that's 6, and that ends up being 1 over x.